Hello and welcome everyone. In this chapter, we will start switching. So, this is a very first video of the switching part in which we will have the introduction to switch discussion here. So, to understand this switching, first of all, we need to know what exactly the switch and how many type of switches we have and how switch works and some of the technology like Ethernet. So we will see the each and every switching concept in detail. So let's get started with the very basic, that what is switch and how switch works. So take an example of the same here. See, let's say we have a very basic requirement, like we have the multiple computers and user devices, and we want to connect end user devices to a central point of device. So that's where we have a particular device that we use, which is known as switch. Switch is basically your one of the hub device, you can say, where all the devices will get connected. Make sure switch is one of the very fast and very fast operating device, which has RAM, and it has the iOS, the operating system of Cisco, and it has ASICs. ASICs is basically just like a processor. ASIC is basically like a processor for the switch, brain for the switches, you can say. ASIC stand for application specific integrated circuit. Application specific integrated circuit. And this all the things will be integrated on the motherboard of your switches, and you will find there will be two cable, you can say, connected from here to here to each and every switch ports. So basically this is your connections from your motherboards to your actual ports, and you can say two cables are connected here in simple term. That's nothing but, the use cases is nothing but one cable will be used for your transmit, one is for your transmit, another one is for your receiving. That's very important point you need to understand. Transmit and receive, simple. So make sure switch is one of the fully managed device where we basically use to connect the multiple end user devices together, and basically it forms the star topology as well. So let us try to understand how switch works. So the couple of major points to remember before know how the switch works actually. So first of all, I have connected here multiple computers which has the MAC addresses like AA, BB, CC and DD, and the IP addresses are also I have configured, let's say, from the same network range like 10.10.0.0.1, 2, 3 and 4, like this. So now see how the communications can take place from one PC to another PC. Say for example, I will consider this is my source device and this is my destinations. So normally once you have connected your devices physically and assign the IP addresses, you need to go ahead and test your connectivity by giving ping command. And the moment you define ping command, it will be handled by your ARP request and ARP response. Of course we know that ping is all about it is going to basically make use of your ARP request and ARP reply. This is very important point. So let's try to understand how it works. So let's say the moment you say ping to this particular 10.0.0.4 from this PC AA, then let's say what happens here. So let's say it says that ping to 10.0.0.4. So now it will say my source IP address is 10.0.0.1, my source IP address is 10.0.0.1 and source MAC address is AA. Who is this destination 10.0.0.4? Give me your MAC address. This is basically a very basic packet get encapsulated here, and this will be considered as your ARP request. So the moment you go to this device and define ping 10.0.0.4, it will generate this particular ARP request. And this ARP request goes to switch. Now switch will say that, hey, I am receiving one of the request here. So let me maintain some of the information here. Switch is going to maintain one of the table which is known as MAC table, which is known as MAC table, MAC address table. It says MAC address AA, and it is coming from which port? Port number 1. Simple. And after that, switch will check what is the destination MAC address here. It is unknown, broadcast. So if it is broadcast in the sense, switch will go ahead and simply forward this request to each and every active ports in the switches except receiving port. Means your ARP request goes to port number 1. Switch will maintain the MAC address table by learning the source MAC address, and then switch will do the flooding of your request. Means switch will send that request to port number 2, port number 3, port number 4. I mean, for all the active ports it will forward. It will not send that particular request back to port number 1. Now see, this will receive, they will check the MAC IP address 10.0.0.4 matching with this. No, it will drop the packet. Matching here? No, it will drop the packet. Matching here? Yes, it is matching. Now it is going to generate the ARP response, in which it will say that now the source will be this, like 10.0.0.4, and MAC address is DD, and destination will be 10.0.0.1, and MAC address is present in that particular ARP request, and this is basically your ARP response, or you can say that it is your ARP reply. Again, this information goes to switch. Now switch will simply learn the MAC address DD coming from port number 4, and what is the destination? Destination is AA. AA is there in the MAC address table. Yes, connected to which port? Port number 1. Now this request will be simply forwarded from here to here. So switch basically works with flooding and unicast. ARP request is always broadcast, where switch will perform the flooding, and ARP response will be always unicast in the switches. So this is how your switch works. Make sure switch is your layer 2 device which works with the flooding and unicast. There is a difference between broadcast and unicast, broadcast and flooding. Okay, so make sure this is how your switch works. Now, taking one more example in this itself. Say for example, as we know, we was having some of the other device like this. Say for example, this is some of the device here, and number of computers, of course you can go ahead and connect here as well. Let's say MAC address is, let's say A, MAC address is B, and IP address is, let's say 10.0.0.5, 10.0.0.6, and we have connected this particular from here to here. So what exactly is this? If you see in this case, I am going to consider this is basically my hub device. This is hub device. Before switch, we used to have the hub, and hub itself was the device that we was using to connect your multiple devices. As we know, there is a problem in hub. For example, whenever this trying to send some data and this also trying to send some data at the same time, there is collision will take place. Collision will take place, and this collision is basically, this collision will take place, and this collision is basically a problem. This collision traffic may forward it to the switch as well, but whenever this collision traffic comes to this particular switch, port number 6, your switch will go ahead and stop this particular collision traffic. Means switch has the intelligence to stop the collision traffic as well. Only one port will get affected here. So that's the main reason in the switches, by default in the switches you will find a single broadcast domain and per port collision domain. This is very important to remember. So that's it guys, this is how your switches works. Let's move ahead and see a couple of more information in the slide deck as well. So this, see, Switch, as we discussed, switch is basically one of the layer 2 device, and layer 2 is nothing but your data link layer device. It maintains the MAC address table, and switch basically creates your star topology. Generally, we use the switches to connect your end user devices. By default, switch has the single broadcast domain and per port collision domain in the switches. And make sure each and every switch has the ports, and the ports are basically considered as your Ethernet port, you can say that. So that's what here Ethernet is the most popular physical layer LAN technology, and Ethernet standard is basically become the open standard, which is known as IEEE standard 802.3, and the speed for Ethernet is 10 Mbps. But later on this Ethernet gets enhanced, and we have the different version of it, where you have Ethernet 10 Mbps, fast Ethernet 10 Mbps, fast Ethernet 100 Mbps, gigabit Ethernet 1000 Mbps, and 10 gig, it is your 10,000 Mbps of a speed that we have. So depends upon the switches series and the switches model, you will find the Ethernet or maybe fast Ethernet or maybe the other ports also in the same. So this is basically a quick introduction to your switches, and thank you. See you in the next lecture with the updated information. Thank you.